Okay, number 3. Remember we scribbled out and wrote the interval on -2 to 2. So make sure you fix that first. Okay, so let's go through our integral here from our 1 over b minus a times the integral of from a to b of f of x dx. That's our formula. So when we plug that in, we'll get 1 over 2 minus -2 times the integral from -2 to 2 of 4 minus x squared dx. Okay, so if we simplify the fraction, that'll be 1/4. So I'll have 1/4 times, okay, the integral from -2 to 2. Yeah, I'll rewrite it. -2 to 2 of 4 minus x squared dx. Okay, so now let's integrate 4 and integrate x, -x squared. So this would be, the integral of 4 is 4x minus the integral of x squared is 1/3 x to the 3rd from -2 to 2. And then we'll times whatever we get in there by 1/4. Okay, let me just double check myself by taking the derivative. All right, looks good. So I'm gonna plug in 2 and then subtract the -2. So be careful with all your signs. So I'll have 4 times 2 minus 1/3, 2 to the 3rd minus 4 times -2 minus 1/3 times -2 to the 3rd. Okay, so this is 8 minus 8/3 minus -8 plus 8/3. Okay, so when you distribute the negative here, this will be 8 minus 8/3 plus 8 minus 8/3, which is 16 minus 16/3. And we gotta times that by 1/4. Or you could just type all of this in the calculator and press equals. As long as you use enough parentheses, it'll work out. So I'm just gonna, to help me out, distribute the 4th here. And that'll give me 4 minus 4/3. That's 12/3 minus 4/3, 8/3, okay? We don't want to be putting 0.26666, whatever it ends up being. Especially for the next part, you'll see. You want it to be a nice fraction. All right, 8/3. Okay, so we've had those 3 done, and now I ran out of room on the other videos, so let me write what we got for these. 16, 2 over pi, and 8/3. Okay, so let's answer this other question here. At what point in the interval does the function assume its average value? In other words, find c. So we found what f of c was, but now we want to find c. Okay, so how we're going to do that is set f of x equal to f of c and solve. Okay, so what do I mean by that? I'm going to set f of x equal to f of c and solve. That will give me what c is. Okay, so for the first one, to find c, that will give me the point in the interval. So for the first one, in the interval from 1 to 4, in which 3x squared minus 2x equals 16 for the first one. Okay, so let's figure out what that is. I'm going to subtract 16. 3x squared minus 2x minus 16 equals 0. We have to factor that. So we'll move the 3 back. X squared minus 2x minus 48 equals 0. And what will times to 48 and add to negative 2? X minus 8, x plus 6. Yeah, that works. Okay. And then since we slid the 3 back, you gotta divide it out. If it doesn't divide, it bottoms up, right? So 3x minus 8 and x plus 2. Those would give me the solutions, 8/3 and negative 2. Okay? So my potential C's are 8/3 and negative 2. But I have to be in the interval. So the only solution that'll work for C is 8/3. That's the only thing that's in 1 to 4. Okay, so that's an example where you're gonna have to factor to find that value. All right, next. So we need to find C, our point in 0 to pi, close bracket, 0 to pi, in which sine x equals 2 over pi. Okay, in which sine x equals 2 over pi. So, when you have a sign with the x, the way to get rid of that and have just x is to inverse sine both sides. So we'll have x equals the inverse sine of 2 over pi. Make sure your calculator mode is radians. So I'll just go inverse sine 2 over pi. And we'll have to round this 0.69. Or you can do 0.7. And just check that that's in the interval. 0 to 3.14 definitely is. So that's what C is going to be. That's going to be the point in which you have the actual average value. Okay, so if you think you got the third one, try that on your own and pause the video. If not, you can just watch. So we want point on negative 2 to 2, where 4 minus x squared equals 8/3. Okay, so how would I find this? I'm going to subtract 4. So it'd be negative x squared equals, well, if we try off to the side to find what that is, 8/3 minus 4 is 12/3. So that'll give me a negative 4/3. Okay. Then we're gonna divide out the negative and just get x squared equals 4/3. Okay. So how do we solve? We square root both sides. Okay, and we need to see which one will fit on the interval. We have plus minus square root of 4/3. You definitely could rationalize that if you wanted to, but let's see which one will fit on the interval. So square root of 4/3, 1.15. Okay, negative square root of 4/3, negative 1.15. So they both fit on this interval because we're really square rooting here. Okay, so that means C would be, it would hit the average value at plus minus square root of 4/3. Okay? Okay, let's move on to the back. So we're gonna do integrals in real life, and with these we're not gonna actually find the value, the C, so it'll be a little easier, a little faster. Okay, so if you're given a rate like how fast water is leaking, how fast an object is cooling, the integral will give you the original amount in the problem. Okay, for example, if you're given a rate at which water is leaking out of a cup, the integral would tell you the total amount of water that is leaked out of the cup after a certain amount of time, which would be like the start time to the finish. So it tells you that amount or that area, however you want to think of it. We should kind of know that already. But what does the average value in real life tell you? It would provide you with the average rate of flow of the water leaking out of the cup over an amount of time. Okay, so how the average rate it's flowing in, leaving, coming out, or filling up, that's what you're finding here. Okay, so let's do this one. The rate at which water flows out of a pipe in gallons per hour is given by a differentiable function R of time t. The rate of the water flow, R of t, can be represented by, or approximated by Q of t, 1/79 times 768 plus 23t minus t squared. Okay, so this is just an approximate value and our new function. So use this to approximate the average rate of water flow during the 24-hour time period. Indicate units of measure. Okay, so if we're trying to find over an entire day, a 24-hour time period, that would make our integral from 0 to 24. And if we wanted to find the average, we'd have to do 1 over b minus a. This would be our average rate of flow. Okay, so that's what we need to find out, and we'll indicate our units of measure. Okay, so that would be 1 over 24 times the integral from 0 to 24 of 1 over 79, 768 plus 23t minus t squared dt. Okay, so this 1 over 79 is just a fraction. I'm going to pull it out front. It's a constant. And let's go ahead and figure out what this would be. So I'll do 1 over 24. Hold on. 1 over 24 times 1 over 79. Math, enter, enter. Okay, so 1 over 1896. Okay, and then we'll integrate here. Okay, so the integral of 768 is 768t. The integral of 23t to the first would be plus 23 over 2t squared. Take the derivative and check yourself real quick. You should end up what you started with. Okay, minus 1/3 t to the third. And then I need to squeeze in from 0 to 24. Okay, so I'm going to ignore 1 over 1,896 for now and plug in 24 and then subtract 0. So I've plugged in 24 for t. And if I subtract and plug in 0, I'd get 0 plus 0 minus 0. So the 0 actually isn't going to matter. Okay. Okay, so we really just got to figure out what this is. All right, so I'm getting 1, 8, 4, 3, 2. Plus 6, 6, 2, 4. Minus 4, 6, 0, 8. Okay, so 1, 8, 4, 3, 2. Plus 6, 6, 2, 4. Minus 4, 6, 0, 8. So I'm at 1 over 1, 8, 9, 6 times, oh, I didn't really need that fraction bar, sorry. 2, 0, 4, 4, 8. Okay, so if I do 2, 0, 4, 4, 8, all over 1, 8, 9, 6, and then math, enter, I get 852 over 79. Okay. Okay. Hopefully that all worked out. Okay, I'm just checking real quick. Looks good. All right, cool. So,